Yesterday we talked about different regions of the periodic table, and today we're going to start talking about some of the trends. So as you go up the periodic table or as you go from left to right, you can tell certain things about the elements. And the first one has to do with the size of the atom, and we're going to refer to it in terms of the radius of the atom. The problem with this definition is that an atom has no real outside ending, because we learned about before that the atom is, we don't know the exact location of the electrons, and so it ends up looking like a cloud because we're just plotting the probability. So it's hard to find the edge of the atom. So the definition for the radius is if you take two atoms and put them next to each other, find the distance between two nuclei and cut it in half, that's the atomic radius. Don't worry too much about that definition, just understand that when I'm saying to compare the atomic radius of different elements, what I'm asking you to do is to tell me about the size. So circle the word size in your notes. From top to bottom, the atomic radius increases because each time you go down one level, you add an energy level, and we've actually talked about this before. So on your periodic table, you should have numbered on the left 1 down to 7. Those numbers tell you the number of rings, which is another way to say energy levels. So each time you go down a row, you have a new ring on the atom, which makes it bigger. From left to right is a little bit harder because as you go left to right on the periodic table, all the numbers are increasing, so it's tempting to think that the atom would get bigger, but it actually gets smaller, and here's the reason why. As you go from left to right, notice that the atomic numbers increase, and as you stick another proton in the middle of the atom each time you move across, what you're doing is increasing the force of attraction between the protons and the electrons. So as you have more and more protons, the electrons are going to get sucked in closer and closer to the nucleus, which makes the whole atom smaller. So even though the numbers get bigger left to right, the atoms actually get smaller. This is a picture just because visuals tend to help me more than words. Just so you can see, notice that the bottom left have the biggest atoms, so they get bigger as you go down, and the top right have the smaller ones. So they get bigger as you go down and smaller as you go left to right. One way you can remember that is if you just picture a snowman, you would never draw a snowman with the smallest circle on the bottom, so that'll help you remember that it gets bigger as you go down. And then if you draw Frosty on the left, picture Frosty falling into the periodic table, and you can now see that it's going to get smaller as you go left to right. Take a minute and see if you can pause this video, see if you can figure out which of these elements has a larger atom. For the first one, since they're in the same column, barium is farther down, so barium is a bigger atom. And the reason is because it has more energy levels. So when you talk about the reason in terms of up and down, you want to use the term energy levels. As you go left to right, it's going to get smaller. So sulfur is smaller than sodium here. Sodium is larger. And the reason is because sulfur has more protons, which are going to suck in those electrons even more. And of the last four, selenium is on the far bottom left, which makes it the biggest element. It has the most energy levels, and it has the fewer protons. The next one is ionic size, and we talked about before an ion is just a charged particle. Yesterday we learned two new vocabulary words, cation and anion. And remember, cation is the positive one. One way you can remember that is that lowercase t looks like the plus sign. So a positive ion means that it lost electrons, and anytime you lose electrons, the atom is going to get a little bit smaller. So from Cu to Cu+, it's going to get smaller. Anions are the word for the negative ions. So for anions, anytime you gain electrons, they're going to spread out because electrons repel each other. So it's going to get bigger. So from chlorine to chlorine -1, it's going to get bigger. The problem with ions is I'm not always going to tell you what the charge is going to be. So yesterday we learned how to figure out oxidation numbers, which is a fancy way to say charge. So if you look at this picture, it's just kind of a visual to help you understand it. The smallest ones are the positive ones, the biggest ones are the negative ones. So for each of these atoms, first thing you have to do is figure out what kind of ion would it become. So if you take a look at oxygen on the periodic table, it has 6 valence electrons. So in order to become stable and have the 8, it's always going to gain 2 electrons and become a -2. So really what we're comparing is oxygen to oxygen -2. And the negative one had to gain electrons to become negative, which means it got bigger. So in the case for the first one, the bigger one is going to be oxygen's ion instead of the atom. For number 2, though, boron has a +3 charge because it's going to lose those 3 valence electrons, which makes it smaller. So for number 2, the atom is going to end up being bigger. Pause this video and try the next 2 by yourself and see if you get the answers right. The answer for number 3 should be iodine's ion because it becomes a -1, which means it gains 1 electron and becomes bigger. For calcium, it's going to lose 2 electrons and become smaller. So the answer for 4 is just the atom of calcium. And the last trend for today is ionization energy. And the definition for that is the energy required to remove an electron. For this class, we'll just usually talk about removing the first electron, but keep in mind that in future chemistry classes, you'll sometimes talk about second and third ionization energies. The trend for ionization energy has to do with the size of the atom. So the bigger the atom, the easier it is to pull it off, the electron, and the smaller it is, the harder it is to pull off. So ionization energy is going to increase as you go up, and that's because the smaller ones are at the top, so the electrons are closer to the nucleus for the smaller atoms, which means it takes more energy to pull off the electron. The bottom elements have a ton of energy levels in between the outer electron and the nucleus, and those extra energy levels between the outer energy level and the nucleus block the force of attraction, which makes it easier to pull the electron off, and that's called the shielding effect. So the shielding effect is kind of like the idea where you have a refrigerator and you put a whole bunch of papers under a magnet. Eventually the magnet won't be able to feel that magnetic charge from the refrigerator because there's too much stuff in between. And that's what the shielding effect is. Electrons that are really far away from the nucleus have all that stuff in between, and it blocks the pull, which makes it have a lower ionization energy. As you go left to right, you're going to increase the nuclear charge, which is just talking about the protons. So the more protons you have, the tighter those electrons are going to be held onto the atom, which means it has a higher or a greater ionization energy. So the trend for ionization energy, just because the picture helps me, is that it increases as you go up and it increases as you go to the right. And the reason is because way up here in the top right corner you have the smallest atoms, so they take the most energy to remove those electrons. Down here in the bottom left are the biggest atoms, so they're not going to take much energy at all. And that's why it's the lowest ionization energy. So for this last section, find these elements and see if you can tell me which one has a greater first ionization energy. Go ahead and pause this video and see if you can figure it out and then check your answers. For the first one, potassium is way farther to the left and farther down, which means that sulfur has the greater first ionization energy. For the second one, lithium is way higher up on the periodic table, francium is at the bottom, so lithium has a greater first ionization energy. And for the last ones, rubidium is on the left, calcium is pretty close to that, phosphorus is over towards the top right, and neon is way up on the top right. And so since neon is the farthest up and to the right, it means it takes the greatest energy to pull off that electron. And in fact, neon even has another special thing. Neon is stable because it's a noble gas, so that makes it especially hard to pull off that electron. So the answer for 3 is neon. And that's it for today.